Step 1 is to find out dominant or recessive. Ask this question: do unaffected parents have an affected child? If answer is yes, then recessive. If no, then dominant. Step 2 is to find out if it's autosomal or X recessive disorder. The logic is to find an affected female and look at her father and her sons. If the son and the father both are unaffected, then it's autosomal recessive disorder. And why is that? So this affected female has XA chromosomes, and she receives those affected chromosome, one of the affected chromosomes, from her father and gives one chromosome to her sons. And if you see her sons are healthy, then it's definitely not an X chromosome linked disorder. And it's definitely an autosomal disorder. Now on to step 3 to find out if it's autosomal versus X dominant. The logic is to find affected males and look at his daughter. So if the daughter is unaffected of that affected male, then it's autosomal dominant. Why is that? Because the affected male, that is the dad, would have XA and Y chromosome, and he must pass his affected X chromosome to all of his daughters. And if it's not doing so, that is, if the daughter is unaffected, then it's autosomal disorder and not X dominant. Step 4 is to see if it's Y-linked or mitochondrial disorder. If it's Y-linked, only males would have it, and it's one of the easiest one to spot. And if you see even one affected female, then it's definitely not Y-linked. For mitochondrial disorders, if the mother is affected, all of her kids would be affected. If the father is affected, none of the kids would be affected. Common pedigree if you want a cheat sheet.